Hey everyone, this is Caroline, one of your graders for Mech Design 2. Today I'm going to give you all a quick refresh on how to create a bill of materials. Hopefully this is a review for you and you kind of remember this stuff from SolidWorks and DML. If this is all new for you or you're having trouble, feel free to email me at cme@ufl.edu. Let's jump right in. What is a bill of materials? An engineering bill of materials, also known as a BOM, is a list of parts, assemblies, and quantities that are needed to assemble a full product. The BOM is a means of communication and record keeping. Below you can see a picture of the template that I've modified for this course. Now, hopefully this looks familiar, but I'm going to break this table down column by column. First, we have the item number, which assigns a single number to every part in the BOM. These are also the numbers that will appear in the bubbles on your assembly drawings. It is important to remember that numbering does not restart from 1 on each assembly drawing. The bubble number pointing to a part should directly correspond to that part's number on the master bill of materials. Next is the drawing number. This assigns a detailed number to an assembly part or OTS part. This number appears in the drawing's title block. How you name each part is up to you, but there should be an obvious order to how it's done. You could use the course code, the product name, or an acronym related to your project. It is important to note that this is not the same part number provided by the manufacturer of off-the-shelf parts, but you will need that for your purchase orders. The part description is the identifying name given to a part or assembly. This also appears in the drawing's title block. Try to keep these descriptions short and to the point. The quantity column answers the question, how many units of this part are needed to assemble the final product? Now I'm going to go over a quick example using a simple assembly for a box I made in SolidWorks. Here I have an exploded view assembly drawing of the box. By looking at the title block, we can see that this part is called Full Assembly and its drawing number is EML 4501-A-01. Next, we can use the balloons and the assembly BOM to determine which parts make up the full assembly. Bubble 2 corresponds to drawing EML 4501-A-02, which is the lid subassembly. The full assembly only requires one of this part. Bubble 3 corresponds to drawing EML 4501-OTS1, which is an off-the-shelf Phillips head screw from McMaster car. The full assembly requires 4 of this part. Bubble 5 corresponds to drawing EML 4501-01, which is a box. The full assembly requires 1 of this part. If we look closer at the lid subassembly, there are some parts that are not mentioned in the full assembly bill of materials. That's because there is another assembly drawing and BOM just for the lid subassembly, which we will take a look at next. In this drawing, Bubble 3 once again corresponds to drawing EML 4501-OTS1, the Phillips head screw. This assembly also requires 4 of this part. Bubble 4 corresponds to another off-the-shelf part, EML 4501-OTS2, which is a surface mount hinge. This assembly requires 2 of this part. Finally, Bubble 6 corresponds to drawing EML 4501-02, which is a lid. This assembly requires 1 of this part. If I was submitting those assembly drawings as part of a project, this is what my full assembly BOM would look like. Remember, the quantity shown in the full assembly BOM should relay how many units are needed for the entire assembly to be complete. All naming and numbering should be consistent from your full BOM to your subassembly BOMs. Finally, order your parts in a way that is clear and makes sense. A common way to do this is from the top down like I did. Start with your full assembly, then descend through all subassemblies. Next, move on to OTS parts. Start with the OTS parts in your full assembly, then work through those needed in subsequent subassemblies. Finally, move on to custom parts. Once again, start with any parts needed in your full assembly, then work your way down through the subassemblies. If you're having trouble with this, I like to sketch out a flowchart. It's a great way to organize your thoughts and make sure your BOM flows in a logical way. Here I have a full assembly that's composed of 3 subassemblies and 2 OTS parts. These could be two different fasteners used to attach the subassemblies to the main assembly. The flowchart also makes it easy to see which parts make up each subassembly. From this example, I would get a BOM that looks like this. I hope you found this review helpful. Please let me know if you have any questions.